Section 5.7, we're doing some more with matrices. So these first couple of problems are, we just have two matrices set equal to each other. These matrices are the same size, or in other words, they have the same order. So the entries would just match up, like 3 is equal to 3, y is equal to 2, x is equal to 5, and 8 is equal to 2z. So in that case, we need to write down the equation and then solve it. So divide both sides by 2, which gives you 4 is equal to z, or in other words, z is equal to 4. Okay, so number 2, so it would be 4 is equal to y minus 3. And then you could just solve for y by adding 3 to both sides. And that would make it 7 equals y, or in other words, y equals 7. And then x plus 2 is equal to 7. And then just subtract 2 from both sides, so x equals 5. All right, so that's that. Then we're going to look at operations that we can do with matrices. Okay, so for adding or subtracting of matrices, they need to have identical size, or in other words, identical order. Okay, so if you're going to add two matrices, you just add up the corresponding entries. Okay, so basically so for this we're going to add a plus b, so we're basically going to do 4 plus 0 to get that first row, first column answer, and then add -1 plus 16 and so forth. All right, so okay. All right. So 4 plus 0 is 4. Let's go down the first column. 0 plus 2 is 2. 7 plus 8 is 15. -1 plus 16 is 15. 5 plus -7 would be -2. And 3 plus 4 would be 7. All right, and that's our final answer for that. And then number 4 says -5b, which means -5 times b, which means we're going to multiply -5 times every entry of the B matrix. Alright, so -5 times 0 is 0. Again, I'm just going to go down the first column. -5 times 2 is -10. -5 times 8 is -40. -5 times 16 is -80. -5 times -7 is 35. And -5 times 4 is -20. that's it. Number 5 says A minus 5B. All right, so we could use the answer from the previous question to speed up the process of answering that. If you do that, though, make sure that you basically add matrix A plus this matrix, okay, because the negative is already here. So you could think of that as the same thing as like A plus negative 5B. Okay, so you could think of it that way, but a lot of times you might see a question like this where you didn't just have a question like that. So I'll probably just go ahead and ignore this and just write it down as if I was, you know, just doing it without this. All right. So if I'm going to do A minus 5B, so I'll start by writing down all my entries from A. Let's see if I can zoom out just a little bit. Okay, so 4, 0, 7, and give myself plenty of space, negative 1, 5, 3. Okay, and then I'll go ahead and just write down the minus 5 times. Okay, and then I'll fill in my entries from B. And then I'll just go ahead and evaluate each one of those. And don't forget about your order of operations. So you would multiply before you would subtract. All right, so basically that's 4 minus 0 is 4. And then 0 minus 10 is negative 10. 7 minus 40 would be negative 33. 1 minus 80, or negative 1 minus 80 rather, would be negative 81. That would be 5 plus 35, which would be 40. And then 3 minus 20 would be negative 17. Okay. And there we have it. And then number 6 says C minus A. We look back up here. C is a 2 by 2 and A is a 3 by 2. So you would not be able to subtract those. So I'm just going to write not possible. All right, because C is a 2 by 2 and A is a 3 by 2. Okay, so they cannot be added or subtracted. All right. Next, we will do matrix multiplication. Okay, so adding and subtracting of matrices, as you saw, was very straightforward, like kind of like you might assume it would be, just adding up the entries. Matrix multiplication is not really like that. It's a little bit more complicated. So, for example, like addition of two matrices, it would be commutative, meaning A plus B would be the same thing as B plus A. However, matrix multiplication is not commutative, so A times B is not the same thing as B times A. even like, you know, when you're multiplying two numbers, you know, multiplication of real numbers is commutative. You know, 4 times 5 is the same as 5 times 4, but again, matrix multiplication is not commutative. So A times B is not the same as B times A. So, first of all, so not all matrices can be multiplied with each other. So first we want to check to see, is it even possible to multiply A times B? So A, in this example, is a 3 by 3. So the order of A, or the size of A, is 3 by 3. And then B is a 3 by 2. Okay, it's rows by columns, 3 rows, 2 columns. So if we want to multiply A times B, so basically the number of rows, the number of columns in the first matrix has to equal the number of rows in the second matrix. So the way I do it is I just write these down, and then I just want to check if these two numbers in the middle are equal to each other. And if they are equal to each other, then that means it is possible to multiply A times B. All right, and in that case, the order of the answer for A times B is going to be a 3 by 2, a 3 by 2. All right, so what if I wanted to multiply B times A? So B, again, let me write the first one down. B is a 3 by 2, and A is a 3 by 3. So if I wanted to multiply B times A, I want to check to see if these two are equal to each other, those two numbers, but they're not. So therefore, B times A is not possible. All right. All right, so A times B, though, is possible. So let's go over how to calculate it. All right, and you can probably find a lot of videos on YouTube of how to calculate matrix multiplication, but I'm just going to go ahead and show you the way I do it. All right. All right, so I'm going to, all right, so I know that my answer is going to be a 3 by 2. All right, so I'm going to start by writing down matrix A with a little bit of extra space in between the columns. All right. And all that is actually going to be involved in column 1 of my answer. So I have 2 columns in my answer. So I'm going to skip some more extra space and write that down again for the second column. Okay, so this is all part of column 1. This is all going to be part of column 2. So now the next thing I'm going to do is I'm going to take the columns from matrix B and I'm going to turn it. Okay, so I'm going to take this first column, 4, 6, -1, and I'm going to turn it. So it's going to be 4, 6, -1. Okay, it's going to be 4, 6, -1. And I'm going to copy those numbers straight down. 4, 6, -1, 4, 6, -1. All right, and then I'm going to take the second column and do the same thing here. So again, I'm taking that second column and I'm going to turn it like this. Okay, so it's going to be 7, -2, -6, 7, -2, negative 6, 7, negative 2, negative 6. All right. And then I'm going to do times plus times plus, okay, times plus times plus times, 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 times plus times plus times. All right. So then I'm just going to perform the calculations to get the answer. Okay, let's see here. So I've got, remember your PEMDAS, you're going to multiply before you add. So basically that's going to be 12 plus 12 plus 4. So that would be 28. All right, then this is going to be 4 plus 0 minus 15. So 4 minus 15 would be negative 11. And then this is going to be 20 plus 48 plus 3. So that would be 68, and then that'd be 71. And then second column, I'm going to have 21 minus 2 plus 24. Okay, so 21 plus 24 is 45. Minus 4 is 41. And then I'm going to have 7 plus 0 minus 90. So that's 7 minus 90, so negative 83. All right, and then 35 minus 16 plus 18. Okay, so negative 16 plus 18 would be 2, and 35, so it'd be 37. Okay, hopefully I didn't mess any of those up. All right. If I did, somebody let me know. All right, and then b times a, so we already went over that. B times a is not possible because of the fact that b is a 3 by 2 and a is a 3 by 3, and these two numbers in the middle are not equal, so therefore it's not possible. All right, and we're just going to do some more examples of matrix multiplication. All right, so C is a 2 by 3, and D is a 3 by 3. So C times D is possible, and the answer for C times D is going to be a 2 by 3. All right, and if we wanted to do D times C, so D is a 3 by 3, and C is a 2 by 3. So D times C would be not possible, because those two numbers are not equal. All right, so C times D is possible, so let's go ahead and do it. So my answer is going to be a 2 by 3, 2 rows, which are the 2 rows here, and then 3 columns. Okay, so again, so I'm going to take the first matrix, I'm going to write it down, maybe a little bit of extra space in between my columns, and I'm going to write it down 3 times for my 3 columns. My 3 columns from D. 3, 0, negative 2, 1, negative 1, 5, and again, 3, 0, negative 2, 1, negative 1, 5. Okay, then take the columns from D, so take that first column from D and then turn it and then put it over here. So 2, negative 3, 4, 2, negative 3, 4. Okay, and then do the same thing with the second column. So 0, 1, 6, 0, 1, 6. In the last column, negative 7, negative 1, 3. Negative 7, negative 1, 3. Okay, and we're doing times plus times plus times. 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 All right, and then we just do the calculations. All right, that's going to be 6 plus 6 minus 4. So that's going to be 8. 0 minus 3 plus 20. So that would be 17. 0 minus 2 minus 6 would be negative 8. 0 plus 1 plus 30 would be 31. Negative 21 plus 2 minus 3. So negative 22. 0 minus 1 plus 15. So 14. All right. And so that would be it. And then, as we said, D times C is not possible. Alrighty, that's basically it. Sorry about that. I did have a page on here for practice problems, and so I thought, what the hey, I'll go ahead and just do this page as well. Alright, so if we wanted to do A plus B, I'm basically just going to do this in my head because it's pretty easy, I think. So 2 plus negative 1 would be 1. 1 plus 0 would be 1. Negative 3 plus 5 would be 2. And 4 plus negative 2 would be 2. Okay, easy peasy there. Let's see, B minus 2A. I'll go ahead and write this one out. So there's my B's. Minus 2 times my A's, which is 2, 1, negative 3, 4. All right, so that is going to be negative 5, negative 2, and then that's going to be 5 plus 6, that's going to be 11, and negative 2 minus 8 would be negative 10. All right, so that should be it for that one. All right, and let's see, A and B are both 2 by 2. So that means both AB and BA will be defined. They are possible to do. All right, so let's see. So A times B, and their answer is going to be a 2 by 2. So A times B. So write down matrix A 2 times. And then B. Okay, so take the column and then turn it. So negative 1, 0, negative 1, 0, 5, negative 2, 5, negative 2. And then go times plus times, times plus times, times plus times, times plus times. Just always start with times and then just alternate it. Okay, so let's see. So that's going to be negative 2, negative 1, and then 16, and then negative 3. All right, and then let's do B times A. So we'll write down B matrix first, 2 times, negative 1, 0, 5, negative 2, negative 1, 0, 5, negative 2. Take the column and turn it. So 2, 1, 2, 1, negative 3, 4, negative 3, 4, and times plus times, times plus times, times plus times, times, oops, times plus times plus times. Okay. All right. So that's going to be 3, negative 2, 23, negative 8. Okay, so there's an example where both AB and BA both existed, but they had totally different answers. All right. Okay, so that's the end of 5.1.